Today we're going to talk about how you can prove triangles congruent without knowing all of their corresponding parts. So first things first, we need to talk about a little bit of vocabulary here. Included angles. An included angle is the angle between two sides. So if we're looking at this triangle here, and let me just say, I want to know what is the included angle, let's say, what's the included angle between, let's see, between AB and BC. Okay, so let's look at the picture. Here's AB, here's BC. The angle would be the one in between those two sides. Look at those two sides I've highlighted. Do not look at AC. Do you see that this would be its included angle right in here? Okay, it looks kind of like the elbow of the angle, right? So its included angle would be angle B. Let's try another one. What would the included angle be between AC and BC? So here's AC, here's BC. What's the included angle? This guy right here, angle C. Okay, let's do one more. What would be the included angle between AB and, let's see, AC? How about that? So here's AB, here's AC. What's its elbow? Right there, angle A. Alright, so angle A would be the included angle. So let's talk about included sides. Included sides would be a side that is between two angles. So if I have, let's see here, if I have angle D and angle E, its included side would be what? Here's angle D. I don't know why my pen keeps doing these weird things. Here's angle E and here's angle D. What's the side included between them? Well, it's literally the side that's formed by them, okay? So their included side would be DE, like that. Okay, their included side would be DE. So let's do another one. We have angle E and we have angle F. So here's E and here's F. Its included side would basically be the side that connects those two. So it's going to be side E, F. Okay? And let's do the last one. The only two angles I haven't talked about as a pair yet is angle D and angle F. So if this is D and this is F, what is its included side? It would be that side right there. It would literally be the side that's formed by the two angles, okay? So you'll need to know what an included side and an included angle is, okay? And I'm also going to kind of walk you through how I do these problems, which is a little different from how I know my textbook teaches it. So there are 4 different ways, actually there's more than this, but today we focus on 4 different ways that you can prove two triangles congruent. You can prove two triangles are congruent if all of their sides are congruent to the other triangle, okay? So side, side, side is what this is called. So if this and this are congruent, this and this are congruent, this and this are congruent, you can say the two triangles are congruent. You don't have to list out any more corresponding parts. The other one is side, angle, side. And let me talk about this to the side here. You don't have to write this down. How do we figure out if a triangle is side, angle, side anyway? So if I have this triangle right here, I'm just going to redraw it over here for you. Say we have this triangle right here. Here's how I think it will help you to tell which postulate it is. I write S or A according to my sides or my angles. So let me talk about what I mean by that. There are 3 angles in this picture, right? I'm going to write an A where every angle is, but I'm going to make my A super big on the angles that are marked. So this angle is not marked, this angle is not marked, but this angle is marked, okay? And then I'm going to do the same with my sides. I'm going to write an S next to each side, but I'm going to make it really big if the side is marked. This side is not marked, this side is marked, this side is marked. Now, as you're going around the triangle, and you're going to go around it like you're walking it, okay? So as you're going around the triangle, you want to go the shortest distance to the biggest letters. So what do I mean by that? If I'm walking and I need to get to the big letters, would I be walking here? No, right? That's longer distance, right? So I would be starting here and going like that. Notice it says SAS, side, angle, side. It doesn't matter which way I do it, side, angle, side on this one, okay? So we'll talk a little bit more about that as we go, but just know that SSS, SAS, side, angle, side, and then angle, side, angle, and angle, angle, side are your postulates. Now here's the deal. You don't really need to remember that whole included side, included angle stuff as much if you use my little method of taking the shortest route, okay? So I'm going to be using that in some of these problems just to make it a little bit easier. I've noticed over the years it makes it a little bit easier for students. So let's go down here. And by the way, you need to remember these 4 things, okay? You can't just be making up whatever you want to use for your postulates. Does the diagram give enough information to show that these 2 triangles are congruent? Well, you always want to check something here. Always look for a shared side, and sometimes you might need to look for a vertical angle, all right? These 2 guys are very important to look for always. So in our picture, do we have any shared sides or vertical angles? Well, we have a shared side. Boom, 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 right there. And a lot of students have a lot of issues trying to figure out what's really going on here unless they break up their triangle. Okay, so if I break this triangle off and I look at it, I need to figure out what postulate it is. Now, some of you are really good. You can look at it and tell me already, but some of you struggle a little bit. So do my method. Put an A next to all the angles. Make your A pretty big if the angle is marked. This angle is not marked, this angle is not marked, and this angle is not marked. Let's put an S next to all the sides. If the side is marked, make it big. S, S, S. They're all marked. So what postulate is this? It looks like SSS. Is SSS an option? It sure is. So, does the diagram give enough information to show that the triangles are congruent? You would say yes. They're congruent by SSS. That's literally your explanation. That postulate is your explanation to me. Okay? So let's talk about number 2. Does the diagram give enough information to use side angle side congruence? Explain. So let's check this out. Do you see a shared side or a vertical angle? I sure do. I see it right here. Right there's your shared side. Now, if you struggle seeing what's going on here, break your triangle off, okay? If you're not seeing it, break your triangle off. Then you want to go around and you want to put an A next to every angle, making the angles that are marked really big. So this angle's not marked, this angle's not marked, but this angle is. Then you want to do the same with the sides. This side is not marked, this side is marked, and this side is marked. Now you want to stay where there is the least distance between those letters. Okay, so it looks like SAS to me. So it says, is this true through SAS? And I would say, yes, it is. Yeah, these triangles are congruent by SAS. And then it says, explain your reasoning. You can say, because there. Like, I can look at that picture and I can see, oh yeah, the student checked it to see if it was SAS. That works for me. That's enough explanation for me. So you are going to try this one on your own. So you try that one, bring it to class. You could pause it now and try it, whatever floats your boat, but bring that one and have it done for class. Going down here, based on the diagram, can you, I don't know what's up with my pen today, can you use the ASA congruence postulate to show, okay, so they want to know if it's angle, side, angle. Okay, so let's look at part A. Looking at this guy right here, they've already broken it off, so there's no shared sides and there's no vertical angles, right? So I'm going to put an A next to every angle, and I'm going to make it really big if that angle is marked. Then I'm going to put an S next to every side, and I'm going to make it really big if that side is marked. So if we go the shortest distance here, we would go like this, right? And is that angle, side, angle? Yes, it is. Yes, it's angle, side, angle. So yes, angle, side, angle works. And it says to explain. Well, this drawing right here is an explanation. That is good enough for me. That drawing right there is an explanation. So I'm going to have you are going to try part B and let me know if angle, side, angle works there or not. Okay? You can pause it now and do it. You can do it at the end. Totally up to you. What additional congruence is needed to show? Okay, students struggle with this additional congruence stuff. They need to show that these two are congruent by angle, angle, side. You always want to mark all your shared side and your vertical angles first. So I do see a vertical angle here, right here, okay? So when it says what additional congruence is needed, it's not that right there because that already exists in our picture. We do not have a shared side. So let's break off this little triangle right here and remark what he has, and then we're going to try to find out what he needs. Okay, so here's our triangle, and let's go ahead and mark our angles: small, small, large. Okay, and then our sides: small, small, large. Now you would like to have angle, angle, side. So looking at this picture, what other part do I need? If I need AAS, and I already have the A and the S, what else do I need? You need another A. You need another angle. But this angle needs to be in the correct spot. You need to have angle, angle, side. So let's discuss this. If I choose this as my other angle, and you look at what's going on here, we'll have angle, side, angle. That's not what we want. We don't want angle, side, angle. We want angle, angle, side. So let me erase that. So then let's try to do this angle right here. Now going the shortest distance means we wouldn't go this way because those have the small letters, 2 of them together. So it wouldn't be the shortest distance. It would be like this. Do you see that this is angle, angle, side now? Okay, so what do we mark in here? What angle did we say we needed? We said we needed angle J, right? So we said we need angle J. Now what would that have to be congruent to in the picture? Now be very careful. I call these the twisted bow ties, okay? What would angle J correspond to in your other picture? What would correspond to angle N, okay? So what do you need? You need angle J to be congruent to angle N to get angle, angle, side. Okay, you need J to be congruent to N to get angle, angle, side. All right, that's the toughest for people. You got to think your way through it. Let's move down here. Does the diagram give enough information to show that the triangles are congruent? If so, state the postulate or theorem that you would use. So let me discuss C with you. C is tricky because if you don't notice these guys or know what they mean, you're really going to slip up. And what those guys mean is that things are parallel. So if things are parallel, we have this going on right now. So if we have that going on, that means this angle is congruent to this angle. And then let me erase those and show you something else. We also have this congruent to this, right? So if we have this going on, we can also say that this angle is congruent to this angle, because what kind of angles are these? Alternate interior angles, right? And then I also want to point this out. Aren't they sharing a side? Okay, so we have alternate interior angles, and they're sharing a side. So let's break this triangle off right here. W, X, Z. This is the same, and then we have this guy here. So let's go around here. This is angle, side, angle. And then if you look, I have to make these guys small. Okay? So look at what this is. Angle, side, angle. Is that a postulate we can use? Let's go and look. Is angle, side, angle a postulate we can use? Absolutely. It's right here. We can totally use it. So going down here, we would say, yes, by angle, side, angle. Okay? So here's what I would like you to do. I would like you to try A and B. Okay, I want you to try A and B. And if you would like to try these down here, you can. But otherwise, we're going to do these in class. It doesn't hurt for you to try them, but we are going to do them in class too. Okay, so that should wrap it up. Go ahead and try the ones that I talked about there, and we will see you in class.